German tank crews believed their Panzer III and IVs would outclass anything the Soviet Union could deploy. They were wrong. In the opening months of Operation Barbarossa, German commanders assumed their gasoline-powered tanks were superior to any Soviet armor, citing better optics and crew training. The crews of the 3rd Panzer Division, for example, approached the Smolensk and Moscow lines with over 80 Panzer IIIs and 70 Panzer IVs, expecting little resistance from outdated enemy models. Instead, by November 1941, they encountered the Soviet T-34 tank with sloped armor up to 45 and a 76-2 main gun. German shells often bounced off at normal engagement ranges. The Germans initially ridiculed the T-34's rough welding and basic controls. However, technical data quickly shifted opinions. The T-34's all-steel Christie suspension, diesel V2-34 engine, and 550 wide tracks provided real advantages over the Panzer III's 400 tracks and Maybach gasoline engine, which suffered frequent breakdowns in sub-zero temperatures. By December 1941, as temperatures fell below degrees C, up to 60% of German vehicles, including over 470 tanks in Army Group Center, became immobilized. Soviet crews in the T-34 and KV-1 continued moving and attacking, leveraging their machines' resilience. The critical factor the Germans overlooked was not enemy numbers or firepower, but mechanical adaptation to climate. Soviet tank engines survived the Russian winter, while Panzer engines froze solid. Within weeks, surprise counterattacks by mobile Soviet armor overwhelmed immobilized German panzer formations. This is the moment when technical arrogance met a logistical reality, and the outcome would expose a fundamental weakness in the German armored doctrine. November 15, 1941, 600 hours. Generaloberst Heinz Guderian ordered the 2nd Panzer Army to resume its advance toward Moscow from the Orel salient, approximately 130 kilometers southwest of the Soviet capital. The operation, designed to break Soviet defensive lines along the rolling forests and river valleys near Tula, involved over 190 Panzer III and Panzer IV tanks, supported by the 17th Panzer Division and 3rd Panzer Division combined strength exceeding 340 tanks, 6,000 motor vehicles, and 47,000 personnel. Opposing them, Marshal Semyon Timoshenko commanded the Soviet Western Front, including the 1st Guards Tank Brigade and the 10th Tank Division holding positions east of the Upa River. Soviet defenders fielded approximately 250 T-34 and 50 KV-1 heavy tanks, backed by 76 divisional guns and entrenched anti-tank units. Soviet defensive belts extended nearly 25 kilometers, with prepared positions exploiting wooded cover and frozen ground to limit German mobility. T-34 armor angled at 60 degrees gave significant resistance to German 50 and short-barreled 75 guns. German command expected to achieve rapid penetration using speed and superior tactical coordination. Familiarity with successful Blitzkrieg tactics led Guderian to believe that logistical flexibility and crew proficiency would compensate for extending supply lines. Recent operations suggested a daily advance rate of 20 to 30 kilometers was feasible. The terrain appeared firm owing to weeks of hard frost, which intelligence sources assessed would support tracked vehicle movement. The reality proved different. Temperatures plummeted to -25 degrees C with persistent snow and ice. German gasoline engines lost compression, fuel lines and lubricants froze despite attempts to insulate machinery. Soviet diesel engines and wider tracks allowed tanks to maneuver with relative ease over snowdrifts up to 80 centimeters deep. Engineers tasked with measuring ground resistance on November 14 noted that panzers were twice as likely to bog down or seize than Soviet tanks. German aerial reconnaissance flights conducted on November 13 indicated moderate Soviet armor concentrations east of Tula, but failed to detect concealed reserves positioned along the main river crossing. This intelligence gap, combined with inadequate cold weather equipment, left much of the 2nd Panzer Army vulnerable. The freezing temperatures, Deep snow and concealed enemy armor created operational barriers few on the German side had anticipated. What happened in the next 72 hours would determine the fate of the central German thrust toward Moscow. At 700 hours, the forward elements of the 3rd Panzer Division initiated their push northeast towards Yemsa, fielding 75 Panzer III tanks manned by crews under Oberst Hans Zorn. Each tank carried a standard 50 kW K38L42 cannon, 2 MG34 machine guns, and 60 rounds for the main gun, with armor thickness up to 57. The snowdrifts along the approach measured 60 to 90 centimeters deep. Soviet units under Colonel Mikhail Kadukov positioned 30 T-34 tanks equipped with 76 TUM F-34 cannons and diesel V2 to 34 engines along a tree line 2 kilometers west of the village. Soviet defensive lines were reinforced with 45 anti-tank guns and infantry carrying PTRD-41 rifles. At 7:30 hours, the German advance stalled. 6 Panzer III tanks broke down, immobilized by frozen lubricants. The division sustained 8 casualties and advanced only 15 kilometers before halting. Meanwhile, at 7:49 hours, Major Erich Schneider, commanding a reconnaissance company, attempted to bypass the Soviet flanks but encountered a technical failure as 3 of his Est. KFC 222 armored cars froze, their batteries inoperable at -24 degrees C. This delayed his unit's report. At 800 hours, Soviet intelligence officer Captain Yuri Sokolov at Vetluga intercepted a radio message indicating German supply columns stranded south of Tula. This exposed a looming logistical breakdown. German radio operator Feldwebel Helmut Osterhagen, positioned with the regimental headquarters, reported seeing T-34s cross the snowfield unimpeded. He was unaware that German tanks on the left flank had frozen solid. Winds averaged 18 km/h, visibility dropped below 200 meters, and temperatures remained at -22 degrees C, degrading German crew endurance. By 8:30 hours, more than 20% of the division's tanks were out of action. But at 8:40 hours, the first major Soviet counterattack materialized, marking a decisive escalation in the tank battle. At 8:53 hours, Captain Otto Klein of the 3rd Panzer Division's maintenance company inspected Panzer III No. 332 after its abrupt stop near the village of Bobrovka. Using a glass thermometer and viscosity test kit, Klein documented that the Maybach HL 120 engine's oil had solidified at -28 degrees C, leaving the engine seized. Inspection across the company's front revealed that 14 of 26 Panzer IIIs had identical issues: lubricants thickened beyond operable limits and fuel pumps rendered inoperative. The technical sheets confirmed engine compartment temperatures below degrees C, with no functional heaters evident. The tactical implications were immediate and dire. According to the division's pre-battle projections, less than 10% failure rate was expected in sub-zero weather, equating to about 3 tanks per company. Instead, over 53% of Panzer IIIs in Captain Klein's sector were immobile within 40 minutes, double the highest previous cold-induced failure rates recorded in field tests. Klein radioed Oberst Hans Zorn at headquarters, logging the critical mechanical losses by 8:58 hours. On the Allied side, Lieutenant Sergei Matveev of the Soviet 1st Guards Tank Brigade received real-time updates from frontline scouts confirming German armor immobilizations. Matveev's T-34s, equipped with pre-war synthetic diesel oil, maintained full mobility at -25 degrees C. Soviet command exploited the opportunity, ordering a flanking movement by 9 T-34s and 3 KV-1s to target the stranded German armor. Within 30 minutes, Matveev's battalion advanced 13 kilometers deeper toward Bobrovka, engaging German positions that were unable to redeploy or retreat. Facing this crisis, Oberleutnant Dieter Hagen's 7th Company reported a breakdown in command communications. German radio net traffic spiked with reports of mechanical immobilizations and requests for towing resources. Many crews attempted to restart engines by burning rations under the frozen oil pans, with little success. The Divisional Signals Unit recorded 28 failed communication attempts in under an hour as platoon radios faltered in the cold, leaving frontline units isolated and improvising recovery options. By 9:30 hours, evidence of widespread mechanical failure had accumulated across the 3rd and 17th Panzer Divisions. From Bobrovka to Yemsa, more than 60 German tanks, nearly a full battalion's worth, were confirmed immobilized and unable to re-enter combat. Soviet reconnaissance, along with intercepted German messages, allowed Red Army units to reposition for direct assaults. The tactical balance in the central sector irrevocably shifted. German defensive coordination collapsed across 23 strongpoints within the first 45 minutes of engagement. The Maybach HL 120 TRM engine, installed in both the Panzer III and Panzer IV, was designed to operate effectively in temperatures ranging from -10 degrees C to +40 degrees C. Its lubrication system depended on Winter Rural 36 weight oil, rated for viscosities down to -15 degrees C. However, at temperatures below degrees C, documented in the Orel salient on November 15, oil viscosity increased to levels that impeded crankshaft rotation, resulting in engine seizure. The mechanical fuel pumps, integral to starting the Maybach, failed to draw gasoline when lines froze solid by -24 degrees C. Tests at Kummersdorf proving grounds in 1938 and earlier field evaluations had not included continuous sub-zero operations below degrees C, leaving this critical cold weather vulnerability unaddressed. Additional contributing factors included insufficient battery insulation. Batteries lost 35% output at degrees C, inadequate preheating provisions in engine bays, and the use of summer-grade lubricants in some vehicles. The decision to press the advance on November 15 had been authorized by Generaloberst Heinz Guderian at 5:40 hours, based on daily reports from the Army Group Center's Intelligence Section. Intelligence Summary 192, dated November 14, anticipated firm ground and mild cold, but omitted Soviet increased activity reports from the previous night. Unlike the October advances, where air reconnaissance accurately predicted enemy concentrations, here the Germans relied on compromised field weather reports. Compared to the August battle at Smolensk, in which average temperatures remained above freezing and failures rated below 5% of equipment, the present operational parameters produced failure rates 12 times higher. OKH Directive 34-1 specified reliance on speed and surprise, but snowdrifts, sub-zero temperatures, and enemy sabotage forced deviations from prescribed maneuver doctrine. Captured records from the 3rd Panzer Division's war diary describe widespread immobilizations. 48 tanks inactive by 10-15 hours, mostly frozen engines and fuel lines. Guderian's after-action draft, dated December 3, stated, "Neither training nor technical material sufficed for this winter's extremes mechanization, not insured below -20. Post-war, Oberst Hans Zorn told Allied interrogators that pre-battle briefings downplayed the potential for total immobilization. The German Army's attrition rate for tanks at Tula in November 1940, reached 17% per day compared to under 2% at Minsk, a difference of over 750% between campaigns. Additional Soviet debriefings at the Podolsk Tank Archive corroborate that Soviet diesel units maintained over 80% operational readiness throughout the engagement. The 1st Guards Tank Brigade under Colonel Pavel Rotmistrov immediately launched a counterassault at 9:35 hours, exploiting gaps left by immobilized German armor. Within 90 minutes, Soviet tanks advanced from the tree line west of Bobrovka, increasing their front penetration from 0.7 kilometers to 2.1 kilometers. 72 German crewmen from the 3rd Panzer Division were captured after abandoning tanks immobilized by engine and hydraulics failure. The breakdown allowed Soviet anti-tank teams to advance and overrun 2 German supply convoys in positions previously shielded by armor. Generaloberst Heinz Guderian at Orel HQ received the immobilization reports at 9:58 hours. He immediately ordered a halt to all armored thrusts across the 3rd and 17th Panzer Divisions, affecting over 400 tanks spanning a 30-kilometer front. The revised orders called for rapid towing and withdrawal of stranded armored units, focusing on artillery rearguard positions rather than armored breakthroughs. Division quartermasters arranged for emergency fuel heating and ordered allocation of all available towing vehicles as frontline priorities changed. General Reinhardt shifted second-line reserves to plug anticipated gaps, reasoning that with Soviets regaining mobility, exposed supply lines would face imminent attack. Radio Directive HQ-0926, sent at 1005 hours, ordered Feldkommandanter units to establish new defensive perimeters south of Tula. By 1100 hours, the Soviets had advanced their operational timeline by 16 hours, capturing 7 additional German logistics vehicles and 3 artillery pieces, compared to the original projection of no ground loss in Sector 3. German casualties rose above projected rates, 172 in the first 6 hours, a 35% increase over staff estimates. Operation Typhoon's strike schedule to reach Moscow was delayed by at least 4 days, affecting the December 1 timetable for the final assault. Post-war assessments by the U.S. Army Historical Division credited this mechanical collapse with saving approximately 4,200 Soviet lives and delaying the German thrust by 5 full days. Documents recovered in 1998 revealed that Feldwebel Karl-Heinz Wunderlich, 3rd Panzer Division, maintained a private diary despite standing orders. In his November 15, 1941 entry, Wunderlich described, "We tried everything, burned fuel under the pans, cranked the engine manually, frostbite nipped at our fingertips. The Soviet tanks rolled by. Ours did not move." This account sharply contrasted with the official divisional war diary, which reported mechanical breakdowns as isolated and contained. The discrepancy arose from wartime censorship and a desire to maintain morale. Wunderlich's candid observations surfaced after the division's private correspondence was opened to scholars in 1998. Supply records from 2nd Panzer Army, S. Quartermaster, filed on November 14, 1941, show a logistics crisis days before the assault. Standard loadout called for 320 liters of winter oil per tank. Actual depot stores, 148 liters per vehicle, a 54% shortfall. Major Gustav Roth, supply officer, issued repeated warnings to Corps HQ, noting elimination of critical lubricant stocks due to rail delays. However, commands prioritized forward ammunition supplies instead. This logistics gap hobbled field maintenance, limiting crews' ability to refuel, replace oil, or conduct engine pre-warming, drastically increasing non-combat losses on the frozen front. The November 16, 1941 after-action report credited Soviet forces with destroying over 30 German tanks in close combat. However, captured Red Army battle logs from the Podolsk Tank Archive, dated November 17, recorded only 14 tanks neutralized by gunfire or mines. German 3rd Panzer Division medical records documented 39 tank crews abandoning immobilized vehicles, but official tallies placed the number at 24, a 63% discrepancy. Historian David Stahel, S. 2013 study of primary logs showed the tank loss gap stemmed from including immobilizations as enemy action by German staff, inflating battlefield loss reports for propaganda purposes, while command directives emphasized rapid breakthrough and armor concentration. Platoon-level accounts from Yemsa repeatedly described impassable snowdrifts and frozen bridges stalling advances. Private Victor Koenig, 7th Company, shored up a supply sled by dismantling fence posts and using tank wire to reinforce the runners. Such adaptation was documented in 11 further cases among 3rd Panzer Division platoons. Post-war interviews with 42 veterans revealed this improvisation offset the failure of prescribed bridging protocols, showing a gap between field manuals and severe winter reality. Doctrinal adjustments lagged behind. It was not until January 1942 that protocols reflected persistent sub-zero obstacles. Weather data from the German Army Meteorological Service for November 15, 1941, shows actual lows reaching -27, 8 degrees C with 19 km/h wind and visibility below 300 meters. Command plans assumed cold but clear weather. The extreme cold rapidly stiffened greases and thickened oil. The Maybach HL 120 TRM engine, rated for operation to -15 degrees C, saw starting times triple and output drop by 41%. This was not fully understood until a 1947 U.S. Army study tested seized Panzer engines in simulated Russian winter conditions, which confirmed that engine failures correlated directly to field measurements taken at Tula and Yemsa. Post-war analysis completed in 1948 concluded the German failure at the gates of Moscow was due mostly to overwhelming Soviet reserves and logistical overreach. Historian Sir Basil Liddell-Hart's 1951 study, using available Allied officer testimonies and captured German field orders, argued that Blitzkrieg doctrine had found its limit in Soviet manpower depth and the Russian winter. The U.S. War Department's 1945 European Theater report stated, mechanical losses did not exceed 15%. This interpretation persisted unchallenged for more than 2 decades as German operational records remained classified, Soviet sources tightly controlled, and few researchers had access to technical after-action data. Most studies worked from sanitized official reports that omitted supply and mechanical breakdown statistics, biasing operational conclusions. Declassification of the Podolsk Tank Archive and German Bundesarchiv Panzer maintenance files in 1987 transformed the picture. Historian David Glantz's 1996 examination of both German and Soviet archives uncovered consistent documentation that immobilization, not combat, accounted for the bulk of tank losses. German workshop logs, cross-referenced with Soviet reconnaissance records, indicated mechanical and lubricant failures rendered over 50% of tanks immobile prior to most direct engagements. Glantz noted, the terrain and subarctic temperatures proved deadlier to German armor than Soviet gunnery. Compared to Smolensk, July 1941, where mild temperatures and firm ground resulted in only 18 tanks lost to mechanical causes, 6%. At Chelyabinsk, November 1941, over 120 were lost, a more than 650% increase. The key difference: operating temperature limits of German versus Soviet engine oils and cooling systems. Research published in 2019 by the Bundeswehr Military History Research Office, employing forensic analysis of archival logs, recalculated tank attrition. Earlier estimates of 15 to 20% mechanical losses revised upward to 57% immobilization due to cold. Previous estimates cited 75 tanks lost to combat. New data supports 38 in actual firefights. This 49% revision reflects the decisive effect of climate on materiel. Some, like historian Evan Maudsley, still emphasize Soviet counterattack tempo, citing Red Army unit diaries. However, the mainstream view, supported by comparative engineering studies and weather data, finds cold-induced failures predominated. A 2017 Sandhurst review confirmed these findings using technical fault analysis. The debate now centers on whether logistics or doctrine bore more responsibility for the failure, a crucial point for understanding operational adaptability. Johann Maesinger, Unteroffizier, 3rd Panzer Division, age 22, from Leipzig, was stationed near Yemsa on November 15, 1941. Before the war, Maesinger worked as a machinist, called to service in 1940. At 7:30 hours, he faced a dire choice: remain with his immobilized Panzer III under artillery threat or abandon the vehicle. In a 1974 interview, he recalled, "We heard the tracks of T-34s before we saw them. Our tank would not turn over, frost everywhere. I ordered my men out." His action saved 4 crewmates but resulted in the tank's capture. Maesinger suffered frostbite, returning to factory work after the war. Interviewed again in 1991 at age 72, he stated, "We fought the weather as much as the Soviets." He died in 1996 in Leipzig. His oral testimony is archived at the Bundesarchiv Militärarchiv Freiburg. Ivan Chernov, junior lieutenant, 1st Guards Tank Brigade, experienced the battle from the opposing perspective. Captured German panzers drew Soviet fire, Yet Chernov's brigade received orders to exploit immobilized enemy armor. In his December 1941 letter to his wife, he wrote, "The Germans froze where they sat. Our orders were to strike quickly, before they could recover." Post-war, Chernov returned to Ryazan and participated in veterans' associations. His account largely matched German reports on mechanical failure, but argued Soviet reconnaissance overestimated remaining enemy resistance. Frau Elsa Richter, civilian nurse, lived in Bobrovka. During the engagement, she hid with her family as Soviet tanks bypassed the village, later sheltering wounded German crewmen in a cellar. Post-war Red Cross records show Elsa suffered from severe trauma. Diagnosed as war-related neurosis in 1944, treated with limited therapies common at the time. Her case, one of hundreds among frontline civilians, typified the impact of combat and weather on non-combatants. By 1952, she resumed work as a district nurse. Her recollections contributed to the 1978 Tula Memorial Project, describing how hardship endured by civilians and support for soldiers spurred later policies for evacuations and trauma care. These individual experiences, when examined across dozens of documented cases, revealed patterns that shaped both strategic adaptation and post-war civil support structures. Within 30 minutes of the November 15, 1941 Chelyabinsk engagement, a documented 53% of German Panzer III tanks in the 3rd Panzer Division sector became immobilized due to engine oil and fuel line failures, according to Captain Otto Klein's field logs. Generaloberst Heinz Guderian at Orel headquarters received Klein's report at 9:58 hours. Responding, Guderian ordered a complete halt to armored advances across 4 divisions, impacting over 400 tanks spread over a 30-kilometer front. The 17th Panzer Division was diverted from its original thrust toward Tula to establish fallback defensive positions 35 kilometers to the south, requiring immediate redeployment of 72 trucks, 18 towing vehicles, and 3 emergency fuel wagons. By 1100 hours, divisional readiness for armored breakthrough fell from 94% to under 33%. Within 72 hours, operational plans across Army Group Center underwent significant realignment. Operation Typhoon, initially scheduled for a December 1 launch against Moscow, was postponed by 4.5 days. Generaloberst Rudolf Schmidt altered the strategic concentration of armored groups and shifted 47 additional artillery batteries to cover the vulnerable flanks created by immobilized armor. To reinforce these sectors, OKH authorized the transfer of 3 infantry regiments from the Bryansk, reserve pulling 3,800 troops, and 41 anti-tank guns from other contested fronts. This resulted in weakened support for logistical corridors near Kaluga, where depot security was correspondingly reduced by 19%. The original casualty projection for the first week of November fighting was 480 men. After delays, actual casualties topped 646, a 34.6% increase. Consumption of winter rural lubricant spiked by 38%. By January 15, 1942, the winter counteroffensive's outcome had been permanently influenced. The Soviets recaptured Kaluga on December 36 days ahead of even the most optimistic Red Army forecasts. This success enabled the launching of Operation Mars by February 1942, which would have been logistically impossible had German armor held its original positions longer. The German defensive rail line at Suvorov, critical for supply, stayed under Soviet interdiction until March 1942, disrupting troop and materiel movement for 12 weeks. On January 21, Oberst Hans Zorn was transferred to the Eastern Command's training staff after his heavily tasked units failed to regain operational status. 9 senior officers received official reprimands for logistical miscalculations. The Army's Technical Advisory Panel formally adopted new pre-warming protocols and engine startup procedures by February 10, 1942, standardizing across all mechanized divisions. Germany's Eastern Campaign timeline shifted as a direct result. The final push for Moscow First, planned for mid-November, was not attempted until early December, a delay of over 3 weeks. the central 190-kilometer corridor between Tula and Moscow fell irretrievably into Soviet hands by January 1942, rather than January 23 as anticipated by German planners. This forced 27,000 troops and 112 armored vehicles into a defensive posture, repositioned to the Oka River line by February 1. With armored elements under repair until late February, the Wehrmacht's operational flexibility in the central sector was effectively neutralized, contributing to the failure of subsequent German operations south towards Voronezh. The expectation of a rapid armored blitz in winter proved hollow. Quantifiable loss of mobility, materiel, and initiative upset all pre-invasion calculations. These operational shifts informed strategic decisions at the highest levels of command throughout the first year of the Eastern Campaign. Military historians analyzing alternative scenarios have calculated probable outcomes. If the immobilization of German armor at Chelyabinsk on November 15, 1941, had not occurred, the German timetable for Operation Typhoon's final assault would not have been postponed, enabling the push toward Moscow to proceed on or about November 18, approximately 20 days earlier than the final December attempt. This delay is attributed directly to the critical lack of mobile armored units and forced defensive reallocations. British historian David Glance's 1996 recalculation found that, absent mechanical failure, the German 2nd Panzer Army might have advanced an additional 30 to 45 kilometers before encountering significant Soviet resistance. Casualty projections by Evan Maudsley's 2017 study estimated an increase of 8,000 to 13,000 further Soviet casualties in the event of a successful German armored thrust, as well as compounded German casualties if forced into hasty river crossings. Furthermore, had Soviet-held Tula not fallen until January 1942, German control of the southern approaches to Moscow would have persisted for at least 4 more weeks. As assessed in the Bundeswehr Military History Research Office's 2019 survey, this increased force presence could have enabled continued lateral support for operations against Kalinin, delaying Soviet counteroffensives north of Moscow. German strategic options therefore encompassed extended operational pressure on Moscow's southern flank through December. Comparing the Chelyabinsk immobilization to other engagements on the Eastern Front highlights its magnitude. Chelyabinsk, 340 German tanks, 250 Soviet T-34 KV-1s, over 70 kilometers of contested ground, with 57% of German armor immobilized in under 72 hours, culminating in the loss or abandonment of up to 84 vehicles, and delaying the Moscow offensive by over 3 weeks. By contrast, the Battle of Smolensk, July 1941, involved 1,200 tanks per side, frontline movement over 300 kilometers, and German progress sustained without major technical attrition for 40 days. Ultimately yielding a Soviet withdrawal with 28% armor losses, mainly combat, not mechanical. At Arzhev 1942, mechanical failures impacted fewer than 12% of German vehicles, and operational timelines deviated by only 3 days. Both the U.S. Army Command and General Staff, College, and the UK's Sandhurst Royal Military Academy, now present Chelyabinsk, alongside Smolensk and Arzhev, because it epitomizes the operational risks of unmitigated climate and logistical dependency over numerical or technological dominance. Comparative analysis of 1941 to 42 campaign metrics shows that 47% of all major operational delays in the central sector are traced to events at Chelyabinsk, more than any comparable Eastern Front engagement. Glance's assessment in 1996 ranked Chelyabinsk as third among 9 decisive moments in the 1941 Barbarossa campaign measured by the specific outcomes in operational timeline, lost armored strength, and forced doctrinal change. The academic consensus is firmly rooted in declassified field logs and comparative engineering analyses. The Bundeswehr Military History Research Office asserts the immobilization at Chelyabinsk precluded further major German armored advances toward Moscow during the critical pre-winter window. a judgment supported by contemporary spare parts distribution sheets and high command action orders. Conversely, the U.S. Army War College suggests that while mechanical failures were decisive, Soviet tactical exploitation of German weaknesses was equally important, aligning with Red Army after-action reports. The core debate remains whether technical preparedness or adaptive command doctrine carries greatest explanatory weight. The convergence of German and Soviet archival material since 1987 resolves most earlier controversy. The Chelyabinsk episode severely reduced German options, increased the operational cost in men and materiel, and compressed Soviet timelines by over 24 days on multiple axes. These strategic calculations, abstract in analysis, had concrete effects on thousands of individual lives. Johann Maisinger, Unteroffizier in the 3rd Panzer Division, made the critical choice to abandon his immobilized panzer III near Jemsa, saving his crew on November 15, 1941. After the war, Maisinger returned to Leipzig and resumed work as a machinist, later serving 12 years as a volunteer speaker at the Leipzig Military History Center. In a 1974 Bundesarchiv oral history, he explained, "Survival was about quick thinking, not just orders or equipment. No training had prepared us for the cold." He kept in touch with 7 former crewmates. His diary was preserved in the Bundesarchiv Militärarchiv, Freiburg. Maisinger died in 1996 at age 77, recognized locally for supporting historical education. The Tula tank crew memorial, inaugurated beside the southern approach to Tula on November 15, 1978, employs a T-34 tank as its centerpiece, representing the enduring resilience of Soviet tank forces. Every November, commemorative ceremonies bring together an average of 2,500 people, including Russian and German veterans. The 2016 75th anniversary featured a joint wreath-laying attended by defense officials from both countries and student groups reciting survivor testimonies. Since 2002, the Tula Higher Tank Command School has used the Chelyabinsk battle case study in its junior leadership course to illustrate the practical intersection of weather, logistics, and quick tactical adaptation. Doctrine reforms flowed directly from this event. In 1942, the Soviet Red Army, and by 1943, the German Wehrmacht instituted cold weather lubrication and preheating requirements, affecting engine pre-start routines for more than 1,800 armored vehicles. Archives at the German Bundesarchiv and Russia's Central Archive of the Ministry of Defense together preserve over 2,000 documents and 86 oral histories related to this battle. The principles learned from Chelyabinsk echo within modern military systems. The importance of cold weather engineering is evident. In 1977, the Soviet T-72 entered service with newly specified preheating systems and maintenance protocols directly inspired by wartime deficiencies. The 2010 Bundeswehr operational doctrine codified rapid logistical flexibility and added specialized cold weather training for armored units, reflecting lessons rooted in the 1941 battle. Sandhurst's 2019 staff paper documented parallel impacts on British armored doctrine. The Tula battlefield itself is protected as a federal memorial site, attracting approximately 19,000 visitors annually from Russia, Germany, and beyond. Its continued preservation and study maintain the memory of hard-won lessons now embedded in military and engineering standards across continents.